Soil pH problems have ruined harvests for as long as humans have planted seeds. Long before test kits, synthetic lime, or bottled amendments, ancient farmers faced the same crisis. Modern gardeners dread crops yellowing, roots stalling, nutrients locked away in soil that was either too acidic or too alkaline. Their solution was not chemical, it was geological. A simple clay-water mixture used across multiple ancient civilizations corrected soil imbalance fast enough to save entire growing seasons. This guide breaks down how that method worked, why it succeeded when modern fixes often fail, and how it can still be applied today with precision and restraint. How ancient growers discovered that clay was not dirt, but chemistry. Clay was never treated as ordinary soil by early agricultural societies. In Mesopotamia, the Indus Valley, ancient China, and parts of the Mediterranean, clay-rich earth was intentionally collected, stored, and mixed rather than avoided. Farmers noticed that when they treated their fields with clay slurry, those fields seemed to stabilize much more quickly after things like floods, droughts, or even crop failures. Interestingly, they didn't start using clay just because it was lying around in abundance. No, they chose it because at a chemical level, clay behaves quite differently from sand or loam. Now, you might wonder why clay changes soil pH rather than forcing it. Well, clay particles actually carry a negative electrical charge. This unique property lets them bind with positively charged ions, things like calcium, magnesium, potassium, and hydrogen. These ions are, really the foundation of soil pH balance. When soil swings too acidic or too alkaline, nutrients become chemically unavailable, even if they're present in large quantities. Clay acts as a buffer rather than a blunt correction. Instead of forcing pH in one direction, it stabilizes ion exchange, allowing soil to settle naturally into a productive range. This is, honestly, why ancient farmers saw results quickly without long-term damage. So, how was the clay-water mixture traditionally prepared? Well, historical records and soil studies show that farmers rarely applied dry clay directly to fields. Instead, they created a thin slurry by mixing finely powdered clay with water until it reached a pourable consistency. This mixture was allowed to rest briefly, so heavier particles settled evenly. The slurry was then spread across soil surfaces or poured directly into planting rows, allowing clay particles to infiltrate the upper soil layers rather than forming hard crusts. How this method corrected pH faster than dry amendments? Liquid application allowed clay particles to move immediately into contact with soil colloids. This rapid contact is what corrected pH behavior quickly. Unlike powdered lime or sulfur, which rely on slow chemical reactions, clay begins buffering ion exchange as soon as it integrates with the soil matrix. Ancient farmers noticed that plants recovered colour and vigour within days, not months. Now, here's how you can apply this method in modern gardens, step by step. Begin by sourcing clean, untreated, natural clay. Pottery clay, bentonite, or subsoil clay from uncontaminated land works best. Break the clay down into fine particles and mix it with water until it resembles thin paint. So, you should apply the mixture evenly over the affected soil, focusing mainly on the root zones rather than the entire plot. Then just allow it to soak in naturally. It's important to avoid compacting the surface afterward. Within just a few days, you'll notice that soil structure and moisture behaviour shift quite noticeably. This method, by the way, works particularly well for acidic sandy soils and those overly alkaline garden beds. Now, why does this mixture improve more than just pH, you might wonder? Clay does more than just adjust acidity, you know. It actually improves cation exchange capacity, increases nutrient retention, and, well, it even enhances the soil's water-holding ability. Ancient farmers understood this almost instinctively. Fields treated with clay needed less irrigation and fewer inputs as the years went by. And, interestingly, modern soil science confirms that even quite small additions of clay can dramatically improve long-term soil resilience. So, why do modern fertilizers so often end up making pH problems even worse? Many commercial fertilizers introduce salts that, temporarily stimulate growth while destabilizing soil chemistry. Over time, repeated use leads to nutrient lockout, microbial decline, and increased pH volatility. Clay stabilizes rather than stimulates. It creates conditions where nutrients remain accessible without constant intervention. And, well, this technique was preserved in traditional farming long after empires fell. In parts of Africa, Asia and South America, clay water soil treatments survived quietly in subsistence farming traditions. They were used after floods, during drought recovery, and when land was exhausted from repeated planting. These farmers did not measure pH numerically. Instead, they measured it by plant response, soil smell, and water behaviour. Why instant results did not mean short-lived results. The word instant does not mean temporary in this context. Clay's buffering effect persists because it becomes part of the soil structure. Unlike soluble amendments that, just wash away, clay remains active for years. Ancient fields treated in this way grew crops generation after generation without the need for chemical correction. Why does this method matter now more than ever? Well, as soils degrade under intensive modern use, solutions that restore balance instead of simply forcing productivity are, frankly, essential. Clay water mixtures need no industrial processing, no synthetic inputs, and, importantly, no dependence on supply chains. These mixtures work because they actually align with how soil chemistry functions. That's precisely why, if you're a serious gardener, you should consider revisiting geological solutions rather than relying on chemical ones. Ancient farmers survived environmental instability without laboratories or labels, relying instead on observation, patience and materials that worked with the land, not against it. If you value techniques that have endured for thousands of years and still, quite remarkably, outperform modern quick fixes, well, do subscribe to Botanical Bliss and share this guide. These methods are not relics. They are tools, just waiting to be used again.